We have a fun one. Yes, it's a roll of toilet paper. You'll see what it's for in just a moment. Although I'm pretty sure you know what toilet paper is for. All right, 2, -3, 2, 6, 5, -3, 5, 6. Form a rectangle that is to be rotated about the y-axis. So this is going to be rotated around the y-axis. Okay, here's the purpose for the toilet paper in this math problem. We're going to take everything we see here and we're going to rotate it around. And when we do, everything we just drew comes over here. Because if I take this point 2 forward, then I have to go 2 back. If I go 5 forward, I'd go 5 back. That point right there that we didn't really draw, we just kind of drew through it, that'd be 3 forward, so 3 back. So there's that one. And then there's this dot, and then there's this dot, and the whole thing gets drawn like this. But again, this is a rotation situation, so this point got rotated around all the way around here. And this point got rotated around all the way around here. And this one got rotated around here. And this one got rotated around here. And we have a tube. What we really have is a cylinder with a hole in the middle. And they are asking us to find the volume of the solid form. So I have this roll of toilet paper to kind of demonstrate what we're truly looking at. It's very hard to see because we have this thing where it's like there's this hole in the center that we don't really see. And then we have these little rings around here. There we go. So basically we have a cylindrical tube. And I want to find the volume of that. And the volume of a cylindrical tube is going to be, well, it's going to be big cylinder minus little cylinder. So here's what's really happening. If I said, what's the volume of this, including the hole, then you would say, okay, well, pi r squared h. I used capital R because we're dealing with a large radius right here compared to this one, which is a smaller radius. But then if I said, you know what, don't count the middle, I would need to subtract away the volume of this cylinder in the middle, so pi times little r squared h. All right, let's keep going. So we have residue from the toilet paper. Pi times the big radius. Okay, what's the big radius? The big radius is going to be from the center. Center, like the axis of rotation, the y-axis. That's going to be this. And that distance right there is, you can count it, but you can kind of also see it. It's 5. So big R is 5. So we know that big R is 5 squared. And then what's the height of this entire thing? Well, that would be from here to here. That's going to be your height. And actually, that's going to be the same for the big cylinder and for the little cylinder, the hole that we're going to subtract away, because the length of the toilet paper is the length of the tube as well, right? Right. So 3 and 6 is going to give me 9. So we have a 9 there. Minus, okay, what's the little radius? You probably already see it. That's going to be from here to here. And that little radius is 2. 2, because it's the little radius. All right, you can type that whole thing in your calculator if you want to. I don't want to. Let me show you something cool. There's a GCF here. It's pi times 9, so 9 pi. And that's going to leave me with 5 squared here, minus 4 squared here, 2 squared, sorry. So that gives me 9 pi times 21. So without even using a calculator, we knew this one was 189 pi. Now, lucky us, I have already figured it out in the calculator, but I'm typing it again because I lost it. There we go. So 189 pi cubic units of whatever, which is also equal to 593.761 cubic units of whatever. Let me zoom in a little bit for you here. I zoomed out to show you the toilet paper, and you've seen toilet paper before. Certainly hope so. There we go. That's what we're dealing with.